Welcome. It has just gone 7 p.m. Eastern Standard Time, Wednesday, the 15th of March, and you are watching Regional Wrap, Episode 80. Regional Wrap, providing an insight on the issues affecting regional Australia and giving a voice to regional residents. My name is Bill Bates, and joining me on this episode, Rivers That Flow Under the Sea, is my guest, Distinguished Professor Sean Olm. Sean is a professional anthropological archaeologist. His partnership research with Indigenous communities focus on the persistent problems with archaeology of Australia and the Western Pacific. We're understanding the relationship between environmental change and cultural change using advanced studies of archaeology and paleo-environmental sequences are central to the reconstruction of the human past. His priority has been the development of new tools and approaches to investigate and articulate the co-variability and co-development of human and natural systems. A major strand of his research has been in the field of archaeological science, where Sean leads integrated research programs designed to improve methods to establish chronologies and taxonomic sequence to increase the confidence in data resolution underpinning models of human past behaviour. This ongoing work refines the chronological of human occupation in tropical coastal areas and allows the calibration of archaeological data sets with terrestrial environmental records, creating a potential for much closer integration of these two key sources of information. Sean has applied these understandings to key archaeological issues, including the establishment of correlation between archaeological and climate records in Northern Australia and evaluating the evidence of Polynesian voyaging to the Americas. Welcome, Sean.
Hi, Bill. Well, thanks for the invitation to be here.
It's a pleasure. As we conversed before, this episode was inspired basically by Robin Beedsman's previous episode of underwater exploration on the Great Barrier Reef, and where his technology he was using highlighted the riverbeds that still exist on our seafloor thousands of years after the seas inundated our continental shelf.
Yes, in fact, I collaborate with Rob quite a bit, and that's part of the real challenge, putting all of these expert skill sets together to investigate the deep past. And Australia has a fascinating deep past that most Australians aren't aware of, and in fact, there's a lot about it we don't know yet.
I suppose one of the interesting things about Australia is because it's such a stable landmass compared to the coastal areas of, say, the Mediterranean, Southeast Asia, even along China coast and the Americas. We're sort of blessed with a very stable landmass.
Look, we are, but a lot of the continental shelves surrounding Australia are very shallow. So one of the fascinating things is that for most of the human history of Australia, the continent has looked nothing like it does today. So when Aboriginal people and Melanesian people arrived on the continent, the sea levels were at least 60 to 80 metres lower than they are today. So Australia was connected both to New Guinea in the north and Tasmania to the south, adding another 2 million or so square kilometres of land. So an extraordinary amount of land transforming the very shape of the continent.
And it was a long way to retreat as the sea level came in after the last glacial period, and we've entered this current interglacial period.
Actually, I had cause to look into this recently, and I've done a lot of work in the southern Gulf of Carpentaria, in the Wellesley Islands, Mornington Island, Bentinck Island. And 20,000 years ago, at the height of the last ice age, those islands in the southern Gulf of Carpentaria were actually 1,000 kilometres away from the nearest coastline, which was out near Darwin at 20,000 years ago. And the only other place on the planet where the coastline was so far away to the modern coastline is actually Siberia, I think. So 1,000 kilometres of land inundated by rising seas since the last ice age is a lot of land in anyone's books.
Well, I suppose one thing is, although our sea level today is sort of incremental, during the change from the glacial period to the interglacial period, it would have been much more rapid, but you certainly would have been able to outrun it. But what about the habitat? How did that fare?
Well, let's go back to the first part of that, because so about 20,000 years ago, the global climate was a lot colder, and a lot of seawater was tied up in glaciers across Europe and the North and South Pole as ice. And after about 20,000 years ago, the global climate started to warm up and that ice began to melt and rise, and the sea levels began to rise. But sea levels didn't rise at a constant rate. So there were times when the sea level wasn't actually rising much at all, and then periods where it rose really rapidly. And there were a couple of periods around 12, 13,000 years ago, which are called meltwater pulse 1A and 1B, where scientists think sea levels may have risen tens of meters in the space of a few centuries. Now, that would have made a dramatic impact on some areas of Australia, not all, because the continental shelves of Australia are not all at the same elevation. And a good example of that is actually the Great Barrier Reef. That something I only appreciated recently, actually on the basis of Rob Beeman's work, is that the southern Great Barrier Reef is at a lower elevation than the northern Great Barrier Reef. So when sea levels began to rise, the shelf on the southern Great Barrier Reef, or what is the southern Great Barrier Reef now, was actually inundated centuries before the northern shelf was inundated. So Aboriginal people in northern Queensland would have known for hundreds of years that sea level was rising to the south, and people were adapting, presumably by adjusting their use of country from a dry land country to an increasingly estuarine and then a fully maritime environment as those sea levels continue to rise. But it's not something that happened overnight. Where the impacts were really big were in the Gulf of Carpentaria, where the gradient of the continental shelf is so gentle that there's some estimates that every high tide would have changed the position of the coastline slightly. So if you had a camp or a village site on the coastline, over your lifetime, you would have noticed that sea level rising quite dramatically. And I think envisaging that is a good, strong mental picture about how people would have had to adapt, observing those environmental changes and adjusting their lifeways.
In Northern Australia, in particular, where we had a fairly additional land mass during when the First Nations people got here, when they had to retreat from the water, it would have been interesting if we had information in regards to that change in available space led to conflicts and those sort of things. But I suppose we might not know that unless we do a lot more archaeological digging and things like that.
Well, I mean, this is a really fascinating question. There's actually dozens of Indigenous communities around the Australian coast that have quite detailed histories about sea level rise, and these have been well documented by Aboriginal community traditional owners and non-Indigenous scientists. And it's widely believed that some of these histories may be the oldest continuous oral histories anywhere in the world, because those histories about sea level rise must be 9, 10, 11,000 years old, which is an extraordinary amount of time for those histories to be transmitted orally. But you're absolutely right that there's absolutely no question that losing 2 million square kilometres of the continent to sea level rise must have led to massive adjustments. But there's been a lot of speculation amongst Indigenous scholars and non-Indigenous scholars about what might have happened. A lot of the kind of current thinking leans towards increasing population densities, that like we have today, that Aboriginal communities are really strongly intertwined with their neighbours in trade and exchange and ceremonial relationships. We think that those types of relationships almost certainly pertained in the past as well as the present. So as people were adjusting by abandoning their country or changing their use of their country, they were probably using those alliances and exchange relationships with their neighbours to move or obtain the goods that they couldn't get because some of their country was now underwater. But Bill, going back to something you said earlier, around 11,000 years ago, the sea level was about 50 metres below where it is now, and it was still rising. But around 10,000 years ago, 11,000 years ago, there were actually more islands on the edge of the Great Barrier Reef than there are now, because the rising water was actually surrounding the last interglacial Great Barrier Reef. So I'll just unpack that a little bit. That over the last few million years, sea levels have gone up and down, and sea levels
dramatically.
Dramatic by 130 meters. So 20,000 years ago, at the height of the last ice age, sea levels around Australia were 130 meters lower than they are today, which is a lot to wrap your head around. But what it means is that the coastlines were off the edge of the continental shelf all the way around Australia. But when those sea levels started to rise, in the last 20,000 years.
Just stop you there. Would that be similar, like for a lot of the areas where the continental shelf is? Would that be a bit like now on the Great Australian Bight, you're looking over a great big dip to see the sea?
Well, actually, in some areas, that's exactly what we think might have happened. In other areas, there would have been, I don't know whether Rob talked about this with you, Bill, last time, but there's been massive landslides in some areas of the edge of the continental shelf, over the last tens of thousands of years. So the topography of the shelf edge in some areas is a dramatic cliff, where rivers and waterfalls would have literally flown over. And in other areas, there's a more gentle topography. In some areas, there were probably estuarine features and mangroves persistent. But the last time sea levels were around where they are today was actually 130,000 years ago. And 130,000 years ago, there would have been a predecessor of the current Great Barrier Reef growing down the east coast of Queensland. When the sea levels dipped again around 100,000 years ago, that old Great Barrier Reef got stranded. And so all of that limestone, obviously of the dead reef, was still there. So in the last 20,000 years, when sea levels began rising again, the sea levels surrounded those old limestone features of the very ancient Great Barrier Reef. And we think that those limestone features probably had fresh water on them, had trees on them that nesting birds carrying seeds from other areas. So they were probably quite attractive to people, because we know that islands are very productive in terms of their marine resources, and the more linear kilometres of coastline you've got, generally the more productive and the more people those sorts of environments could support. So it's kind of adjusting your thinking to a very different environment that would have pertained in the past that is now offshore.
But it's only in the last glacial period that the First Nations people entered Australia. So, because actually the movement of Homo sapien has been very late in in geological terms. I mean, coming out of Africa and spreading out and bumping into Neanderthals and all that sort of thing. You're talking about sort of 20,000 years ago or so. So we've made a fair bit of progress in, say, those first 50,000 years getting out of Africa and getting to Australia. That's fairly fast, I would think. I mean, there's a lot of generations in that, but it's still a fair movement to get from Africa across to Australia and then also further up into Asia and across to Europe.
Well, that's absolutely a good point, Bill. And actually, I was reflecting on how dramatically our understanding from a Western science perspective of human evolution has changed since I was an undergraduate student, 30 years ago. So 30 years ago, we thought that modern Homo sapiens sapiens, people who look like you and I, only appeared in Africa about 40,000 years ago. Today, we know in Morocco, in northwestern Africa, that there are ancestral remains of people who look identical to you and I that are 300,000 years old. So 30 years ago, when I was an undergrad, we thought that Aboriginal people had only been in Australia 40,000 years. Now we know that that's more than 65,000 years. And we've just had a paper out where our modelling suggests that first entry may have been 74, 75,000 years ago. And there's a number of lines of evidence coinciding around that 74, 75,000 year mark, which when you think about it, is a dramatic change in the last few decades about how we understand how long people have been in the continent and therefore how people have altered the continent, which is a really fascinating question as well.
I think one of the other interesting part is with the rise in sea level, it was a two-bladed sword, really, because when it came back, the Indigenous people in Tasmania got cut off and locked there, but there was an advantage with the rising sea level that it cushioned our mainland from New Guinea, because the people in New Guinea are much different to our Indigenous people. And actually, I'm not too sure if I wanted to be around about 1,000 years ago, walking around in New Guinea. I might not have a head.
Well, actually, I'll preface this statement by saying that I'm not a geneticist or a DNA specialist, but there's a lot of work with traditional owner communities and Melanesian communities in New Guinea by DNA researchers. And what's really fascinating is that up until 35,000 years ago, there was a lot of gene flow between what is now New Guinea and what is now Australia. But of course, back then it was all dry land and you could walk between New Guinea and Australia. And it's a really puzzling question why gene flow appears to stop 35,000 years ago. I've got a wild theory about it, but it's completely speculative. But there's been no plausible arguments of why basically people stopped exchanging genes across Torres Strait. Now, having said that, Bill, when the sea levels rose, you're absolutely right. We have no evidence that Tasmanian Palawa Aboriginal people continued to move across Bass Strait. There was a lot of use of the Flinders Islands and the other Bass Strait Islands, but what we do know in Northern Australia is that there was no cessation of movement across Torres Strait. So over the last 10,000 years, it appears that there were lots of movement, and that in fact, when the sea rose, islands weren't abandoned. They almost certainly were still integrated into renewed sea countries. So there's very different strategies happening in different parts of the continent as a response to sea level rise.
Well, moving on from there, things like our neighbours down in New Zealand, my understanding that the inhabitation of New Zealand is only about 1,500 years old. Now, what was the movement and where did the movement come to our Western Pacific?
Actually, that's great. I've actually got a useful little map, Bill, that might be useful to share, if you don't mind. I'm just wondering how I'll just share my screen. Can you see that map?
Yep. We can...
So in fact, this map's a couple of years old, but it gives you a general idea that all the red is modern humans like you and I. And you can see it's out of date because I mentioned just before that we now know that this date should be 300,000 years in Morocco, where there's no modern humans. But this is why the peopling of Australia is so important in the global human story, that Australia was actually the first place that modern humans came to that they couldn't walk to. So out of Africa, it was theoretically possible to walk all the way to Bali, but you couldn't walk further east than Bali because there's a very deep strait between Bali and Lombok and Flores. That was always a very deep ocean trench. So when people moved into Australia, it was actually the earliest open ocean sea voyaging we know about in human history. So it's really significant in the whole human story for that reason.
But 50,000 years ago, you'd only be sailing a log.
Well, okay. Let's talk about that a bit, because in fact, there was this idea when I was an undergraduate 30 years ago that Australia could have been peopled by, someone who drifted off course fishing in Indonesia. Over the last couple of years, working with colleagues, we've done really sophisticated modelling, because if only a couple of people arrived on the continent, they would have been well below extinction thresholds. And we know from DNA analyses that there's many different mitochondrial families of Aboriginal communities in Australia, for example. So that means that the original peopling of Australia must have been quite diverse. So our modelling that we've published in the last few years suggests that original colonising population must have been in the order of 1,300 to 1,700 people, and that each colonising event was probably in the order of 70 to 100 people to avoid those very well-known extinction thresholds. So when you start thinking about 70 to 100 people, you're talking about pretty sophisticated watercraft technology, because, it's not simply a log, we might be talking rafts. But
I'm not too sure in Europe that they had anything sophisticated over there that I've heard of. But the interesting part would be, right, you'd have a first lot of people, and then obviously there must have been continuous waves of relatively small groups in today's terms, a couple of hundred, maybe 1,500 or something like that at a time. Do we have sort of DNA evidence in regards to different movements of different groups coming in?
So you're right with something you said earlier, Bill, that these things we're trying to investigate are really in the distant past. This might be 60, 70, 80,000 years ago even. So our tools are really quite limited. So there's two ways we're trying to approach this. One is from a modelling approach, and we're working with ecological modelers who work on, the red list for Bengal tigers and Indian elephants and things like that. So we're trying to understand what the biological limits are. But of course, people aren't just like any other animal. People have culture and cognition that they can plan and adjust to things. The other avenue we've got is that DNA evidence you mentioned. Now, the modelling evidence suggests that the original colonisation would have likely only taken place over a 700-year window. Now, interestingly, the DNA evidence suggests that after people were in the continent, there's actually relatively little gene flow. There's a little bit of gene flow, as I mentioned earlier, over the last 10,000 years that may have happened between Northern Australia and New Guinea. and much more recently in the last maybe 400 or 500 years from Macassan Trapangas and other people who came from the Philippines and other parts of Ireland, Southeast Asia. But there's the genetic ancient DNA evidence, and the DNA evidence really is in its infancy. And there's a lot of traditional owner communities partnering with geneticists to expand that research. So I think we'll learn a lot in the future, but it's really fascinating that there's so little movement of people over such a long period of time.
Are the Indigenous communities interested or enthusiastic about finding this history out as well? Like, are they, because in regards to the general perception that they don't like talking about the dead and all that sort of thing, are they receptive to the idea of finding out this history, or sometimes a bit adverse to it?
Well, that's a really good question, and it basically goes to the heart of respect. Basically, that all Indigenous communities have their own unique history, like any other community, and all of the research that modern researchers do, like myself, is co-designed with Indigenous partners. So all of the communities that I partner with are fascinated to understand their longer term history and have an enormous wealth of detailed knowledge about their own countries, their land and sea countries, and how they've changed over many generations. So I think this is one of the really practical ways that the past can inform the future. That one of the things I'm particularly interested in is that a lot of Australia's current climate and environmental settings are based on a very shallow instrumental record. So even Bureau of Meteorology records and cyclone records, fishery catch records, sea level change records, in Australia, most of those records are far shorter than 100 years old. And we're basing really long-term future models on that very short data set. So one of the challenges that I'm working on in partnership with Indigenous communities is combining Indigenous histories and archaeology and environmental histories to extend that instrumental record. And I think that's going to be critical to understand the full variability of environmental change over the longer term. So I guess I'm saying that, Bill, because archaeology and history sometimes are presented as pursuits of dilettantes in smoking rooms in Western Europe, but modern archaeology and history and other humanities and social sciences are really vitally involved in things that impact on Australia's future. And to answer your question, I mean, all of the research that I do these days is at the request of Indigenous communities who are interested in pursuing various aspects of their history and archaeology on their country. And understanding the long-term history of their sea countries is something that's really emerged in the last couple of years as a real priority for communities.
Well, that's really good to hear, because we know in a lot of instances, I come from West Australia, but I spent most of my time in Victoria, and there's always been some difficulty in regards to excavating and those sort of things. You needed all the proper heritage acts type things, and you need the Indigenous agreements and that. So while you might be encouraged to sort of do some research, is there a time when you know that if you come across something, you have to pause and stop? Are there instances you sort of would recognise, well, we've come across something, we need to stop and we need to engage and withdraw from our current situation?
No, that's a great point. I mean, I guess there's two things I'd say to that. That one of the issues here is that the history of research on Indigenous country and with Indigenous people comes from a very colonial history. So most of the archaeology in this country done before, I mean, literally before the 1990s, often did not involve Indigenous communities or traditional owners. So ancestral remains, so the physical remains of ancestors were sometimes disturbed without consent, and there's that legacy of a lack of consultation. In the modern era, research is co-designed with those traditional owners, and for example, I don't do any work without Indigenous people working with me. So it's not a matter of, I'm working side by side with those Indigenous partners. So, and look, frankly, most research these days, whether it's marine science or archaeology or environmental science, is routinely done in partnership with traditional owners. And it kind of obviates that problem because we're working in partnership and at the direction of those traditional owner communities. And that, frankly, has led to much more productive outcomes, both for the Western science, but also making sure that the outcomes align with Indigenous and non-Indigenous community expectations of what they want to get out of the research.
I suppose, I mean, you can be critical of our past ancestors and their behaviour in regards to digging up things, but when you look at our history in Europe and that, we've been digging up things for hundreds and hundred years, archaeological, and find Stone Age and Bronze Age people and that, and exhumed probably tens of thousands of skeletons, and we don't have that issue in regards to everyone gets it, digging up my ancestors, because basically, if you're in Britain, you don't know really who your ancestor. It could have been a Roman, it could have been a Celt, it could have been a Viking, it could be some other pagan who invaded the place. So we've never had that. I mean, and we even dig up an ex-king of England under a car park in Reading or something like that.
Bill, actually, I think you've hit on exactly what the difference is between continental Europe and places like Australia or the Americas or the Pacific, that when Europeans arrived in Australia, there were people owning the country here who still own large parts of Australia today. So, as we know, that's not the case in Europe. So in that example you used, archaeologists were in fact directly interfering with their direct ancestors' remains. So I think that's a really important difference, because it's meant that archaeology, for example, in Australia, has developed very differently to the way it's practiced in Europe. So, and I think that's a good thing. I think it was a very rocky history, but I think it's led to very productive outcomes today, where we're understanding the past on a much firmer basis by not ignoring those diverse views.
I'm just pointing that out in regards to, we had a standard of practice, and I mean, if you look at Europe, I mean, it's been invaded by all different, the Macedonians, and then you had the Greeks, the Romans. Then you had even other things like Genghis Khan and the Mongols, and you had the invasion from them. So everyone's land's been run over so many times. Especially, I would hate to have my ancestors in Central Europe, like somewhere like Romania. You've been invaded by the Turks, who've had pushed them out. So you've had this splattering of different societies and culture overrun you. I think it's just a matter of sort of acceptance. Well, let's dig up and find out our own history somewhere buried under amongst all that.
And I think that's the fundamental difference too, Bill, that in Australia, when we're talking about the Indigenous past, it's not our history, for non-Indigenous Australians. And look, I think all of these disciplines are maturing, and I think those co-designed research projects are a sign of that maturity. And I think it's part of that kind of broader recognition, I think, that, talking specifically about regional Australia, that Aboriginal people are key land managers in many parts of Australia, but particularly regional Australia, where Indigenous land and sea management groups are really the lead agents for managing those countries. So the more we can understand the past, the more I think we can more productively manage the shared future for all of us.
Now, just going off to the islands a bit, what can we tell from their history in regards to their settlement time, which is obviously a lot shorter than Australia's? But do we have a sort of, like one of the maps showed there was sort of coming out of Australia and New Guinea 30,000 years ago to 1,500 years ago in New Zealand? Is it like going on a bit of a time travel, going down, say, from Bougainville down to Vanuatu, down to Fiji, to Cook Islands, and then further south? Is it like a step? Is 30,000 years, and then we moved a bit further south and a bit further south?
Well, actually, like we were talking earlier, our understanding of this is really changing rapidly. So what we do know is that the people who came to Australia 70, 80,000 years ago were maritime people because of those sea crossings. And the ancestors of Melanesian people made it all the way east to the Solomon Islands. But for reasons we've not really understood, people didn't move further east from the Solomon Islands until the last 3,500, 4,000 years. And those people 3,500, 4,000 years ago were what we call Lapita people. They had a very distinctive form of pottery, and they had chickens and taro and cultivated crops like that. And the long-standing understanding was that a group of people, maybe from Taiwan or southern Vietnam, moved out of those areas maybe 4,000 or 5,000 years ago and moved eastward across what now is island in Indonesia, Papua New Guinea, into New Ireland, the Bismarck Sea, into the Solomon Islands, and then spread to Vanuatu, Fiji, and ultimately their descendants made it to New Zealand. In fact, New Zealand maybe even the last 1,000 years, and ultimately Rapa Nui, Easter Island, in the last millennia, the last 1,000 years as well. But the idea of why, when I was an undergrad, the idea was that people didn't have the sailing technology or the watercraft technology to sail from the Solomons to those more distant islands. Now, what's really fascinating, I've been working with Bengal and Ngaramuku traditional owners up in the Lizard Island group, which is north of Cooktown. And those islands are 35 kilometres off the coast. And we've been working with traditional owners to do a number of archaeological excavations. And some of those excavations show that people were living there 6,500 years ago. So 6,500 years ago, those islands were already 30, 35 kilometres off the coast. And they're quite open oceans between Cooktown and Lizard Island that people must have had quite robust watercraft and, of course, the navigation technology to be sailing there 6,500 years ago. So I think we really need to rethink what we call technologically deterministic views of the past, that we tend to think of people in the past of somehow being simpler than you or I, or having less cognitive power or less technological prowess. But in fact, those very first people who arrived in Australia 70 or 80,000 years ago had the same cognitive architecture that you and I have. So when presented with a problem, people had that neural architecture to come up with a solution. And maybe a solution was to build an outrigger canoe, or maybe build a sail or a paddle, or whatever it might have been. But I think we constantly underestimate the ability of people in the past to find solutions to problems they encounter.
I suppose the thing is, because a lot of these things would have been made of wood, of course, the traces of them are long gone and scattered to the wind. And we probably lacking that sort of clear evidence of those periods and the technology of that time.
Look, absolutely. And this is what makes it simultaneously frustrating and fascinating for people like me. I asked a maritime archaeologist colleague recently what the oldest boat was in the world, and it was only about, I'm pretty sure it was only about 10,000 years old, and it was on the bottom of a lake in the northern hemisphere where those very, very anaerobic water conditions had preserved the wood. So anaerobic, there's very little oxygen, so you don't have bacteria and things leading to decay. But so we need to use other lines of evidence. So with colleagues, I've done a lot of work measuring the distance between different islands throughout Indonesia to get to Australia, and the intervisibility of different islands. And whichever way you cut it, moving through island Indonesia to Australia, even at times of lower sea level, would have required multiple voyages, at least one approaching 100 kilometres, as well as several more than 30 kilometres. So it didn't matter which combination of islands or which direction you sailed, whether you sailed through Timor-Leste to the Kimberley region, for example, or through the Philippines to the Bird's Head of West Papua, you still would have had to make multiple voyages. So for people like me, we have to use a lot of inference to say that, you can't swim 100 kilometres over the horizon on a multi-day voyage. So if you can't swim it, what sort of watercraft do you need? So you need, at least a raft or something. And then you need to provision that watercraft with water or food or whatever. And then we look at those statistics we talked about earlier about avoiding extinction thresholds and things. So we're trying to, in the absence of that physical evidence of watercraft, we're trying to understand what those earliest ancestors of Indigenous Australians must have used. And it's one of those cases where we use all the lines of evidence available to us to try and tell that story.
But the other thing too is, with that sort of island hopping sort of necessity, there would have been a sort of real big breaks in the travel pattern, because there would be an inclination for people when they arrived on, say, a reasonable size island, maybe just to inhabit it and enjoy what's there rather than move on. So it would probably have to be another group following that sort of, oh, well, we might have a bit of interaction with these people, but then we've got to push on. So it would have been a lot of sort of stop and starting. It's not just one continuous progression of massive people walking and other people behind them, pushing them on. It would have been very spasmodic in regards to, well, people got to, say, Indonesian island archipelago. There's lots of land and fertile things there, so a lot of people would have stopped. It's hard to imagine what drove someone to keep moving to the next spot.
Bill, I've just shared my screen again, because I think this is a really crucial point that you've raised, that what I'm showing here, the two blue lines are what are considered the most likely routes into Australia. So a southern route that goes through the Lesser Sunda island chain, through Timor, and Bali's over here, and to what would have been the Paleo Kimberley coast, and a northern route that comes into New Guinea. Now, there's two observations here that our modelling suggests that both routes were used, and that the earlier route was likely the southern route, maybe 75,000 years ago, and then a few thousand years later, the northern route. So there were people moving through these areas. But what happened before that is the question you asked. And there's a lot of genetic work happening in eastern Indonesia at the moment that I'm sure will change this story. But the genetic evidence seems to suggest that immediately before Australia was peopled, that there was a population build-up on these islands. Now, and we think that people were likely exploring. So I don't think you'd load your family onto a raft and sail over the horizon without knowing where you're going. So my speculation is that the Australian coast was already known to people, for example, from what is now Timor-Leste and other places before you moved your family there. And that almost certainly was the case elsewhere as well. Now, I think the DNA evidence will give us more insights into exactly what those populations were. And you might have noticed this human-like figure there, which is actually a reconstruction of Homo floresiensis, who a very famous Australian archaeologist from the University of New England in Armidale, Mike Morwood, found in a cave in Flores called Liang Bua back in the late 1990s. And what he showed was that there was a whole different species of humans living or in Flores at the same time that modern humans were moving through here. So just to back up,
They've been there a lot much longer,
and who'd been there for hundreds of thousands of years. So what's really interesting in this story is that one of our ancient human ancestors, Homo erectus, actually made it all the way to the island of Java, which is just off the edge of this map, by kind of 1.3, 1.4 million years ago. But we've got absolutely no evidence that Homo erectus made it anywhere further east, and doesn't seem to have crossed any of these water crossings. However, Homo floresiensis is this diminutive human ancestor that even a fully grown Homo floresiensis is only about 1.10 meters, 1.20 meters high. So the ancestors of Aboriginal people moving through these islands would have come in contact with this other hominin species. And we now know that there was even another hominin species which has been called Homo luzonensis, found in the Philippines, and it was just published a couple of years ago. So there's a whole lot of research teams working in this island area now, and I'd be absolutely stunned if we don't find more human species in this really productive environment. So to circle back to your question, Bill, it's not only modern humans we're talking about here, it's modern humans interacting with other human species in a very productive tropical environment. So we've got lots of things happening here in terms of population densities, almost certainly the exchange of information and genes with these other hominin species. And we've even got DNA traces of other human species that we don't even have any physical evidence of in New Guinea, for example. And that's a really fascinating story to be told in the future.
I think one of the most interesting things is that in this tropical band, because it's so full of diversity and life and plant life and all that sort of, it supports a myriad of species and provides for a myriad of species, you know, like humans and that, to sustain themselves. That's somewhat different than what it would have been like when you got to some parts of Australia and you don't have that nice tropical, plentiful rainfall, greenery and that. It might have become a bit of a shock to the First Nations people when they got to the Victoria Desert or the Simpson Desert and those sort of places.
Actually, it's really fascinating. We just a couple of months ago, we published an article modelling how quickly the continent of Australia. I'll just share my screen. I think this is a really good way to visualize it. So this modeling was literally published in February, like last month. And what it's showing is these isobands are showing from first landfall how quickly the model suggests people colonize the continent. So within a couple of thousand years, most of the Pilbara is filled. And it only takes a maximum of 8,000 years for even South.
Would the Pilbara then be a lot different than what we know it now? Because I'm not real flash on that place, because it's pretty, to me, it's a fairly barren landscape. And I wouldn't want to leave the lush islands of Java to get there now.
Well, let's unpack that a little bit, because there's a couple of things going on here. That there was a lot more land exposed in this area because sea levels were so much lower. And so the monsoon system almost certainly was pulled further to the north, or have a different pattern than it is today. We think that there was actually a well-watered band of country down what is now underwater land on the extreme western coast. And we think people, in another modelling exercise we did, we think that people may have used those well-watered areas to skirt around the Western Desert. So the Western Desert would have been expanded at that time. In terms of the plants and animals, certainly the plants in Northern Australia have a lot of overlap with the plants of Ireland, Southeast Asia. So at least initially, people would have been encountering plants that were broadly familiar, some of the same species and some related species. But as people, of course, moved further into the continent, they were encountering dramatically different species. The thing that I find fascinating is that the terrestrial animals that people were encountering were very different to the ones they were encountering in Southeast Asia. So until maybe 40,000 years ago, for the first 30 or 40,000 years people were in Australia, I'll just flick through to this one. There were dozens of species of megafauna, including things like this diprotodon, which is a giant wombat ancestor that weighed a couple of 100 kilograms and was 2 or 3 meters high. Giant Stenurus, giant kangaroos, Tasmanian tigers, Jenny Ornis, a giant bird, a couple of 100 kilos. So most of these animals were around for tens of thousands of years after people arrived. So the terrestrial fauna was very different, as well as those plants, as people moved through the continent. So that's another puzzle that Aboriginal people and researchers are grappling with as well.
When we go to our next, maybe climate science, the rest of them we're not going to, but when we get to our next glacial period, and these seabeds are going to be exposed again, will we still be able to trace any sort of human habitation or animal or even terrestrial in regards to flora on what is now seabed, because it's buried under the seabed, and we'll be able to sort of excavate?
Look, absolutely. And this is one of these areas that I've become very involved with, and many Indigenous communities are heavily involved with. So literally for decades, archaeologists have speculated about archaeological sites being preserved on the Australian seabed. But a team I'm involved with, working with the Murujuga Aboriginal Corporation in the Pilbara area, found the first archaeological site on the seabed only back in 2020. So just 3 years ago, those finds were published. And what's really, in that particular circumstance, there were hundreds of stone tools on the seabed. Since that time, we've actually found more artifacts in the Murujuga area. So that's the Burrup Peninsula area off the Pilbara, where there's hundreds of islands with channels between the islands. And those channels, of course, used to be rivers flowing across the dry land, and Aboriginal people were camping in those areas. So what we're really looking for are the remains of those old campsites that are still preserved on the seabed.
I suppose we've got to be thankful that archaeologists can tell the difference between a stone and a stone tool, because most of us would, oh, that's just a rock, whatever, pick it up, throw it somewhere. But I mean, I've seen some of these documentaries where they're digging in that, and they pick up a rock or something like that, and they can tell you what it was used for, and to me, it's a rock. But these people can tell the history of those rocks and what they were used for.
So actually, you've hit on something, Bill, that makes this a real challenge. Now, what I'm showing you here is actually a stone artifact that has been taken from the seabed, and what you're seeing are calcareous growth and sponges and tube worms on it. Now, we actually put this artifact in the nuclear reactor down at Ansto at Lucas Heights, one of the nuclear reactors in Australia, to actually see what's below that marine growth. Now, the way archaeologists tell a stone artifact from just a rock is that using the principles of fracture mechanics. So where pieces of rock have been removed from the stone, we actually can see what we call the point of force percussion. So where one stone has been hit against another to create a very distinctive physical pattern on the rock. So we're using a lot of very advanced technology to find these. I just wanted to show you just two images so you can visualize what these underwater sites look like. These are divers in our team in the water, and this is off the Pilbara coastline. And this is actually what we call a wonky hole. So we have lots of wonky holes along the Great Barrier Reef coast as well. And these are very well known by fishing people because they're often really good spots to go fishing, because fresh water is bubbling up from these wonky holes, because they're actually the paleo watercourses of river channels, and modern rivers are still flowing under the water in the sediments and bubbling up through some of these features. So when we take the water away from a feature like this, and this is our dive boat here, this is that feature. So there's little overhangs and a permanent kind of spring feature on the seabed. And we're finding these stone artifacts scattered around these permanent water features. So it's very difficult when you're in the water diving, Bill. As you said, you hit the nail on the head. It's like a needle in the haystack trying to identify what's a bit of rubble from what's an artifact. And on the boats, we actually have stone artifact specialists and traditional owners. And the divers are bringing up what they think might be artifacts after plotting their location with GPSs. They bring them up to the surface, hand them to the specialists and traditional owners on the boats, who are actually making a decision about whether it is an artifact or not. And for those that we're not certain of, we're taking them to be either imaged using those nuclear resonance techniques, or acid etched to try and look what's below that marine growth. So it's really like the work Rob Beeman was talking to you about. It's really painstaking and sometimes very expensive work, just because of the technology involved, the use of boats and remote sensing, like LiDAR from planes, like shooting lasers into the water, or sonar on boats.
I suppose that's where you've got to be thankful for philanthropists that give you time on their special boats and things like that, because like everything, there's a limit to government money and that, but there are a lot of private people out there who fund a lot of these operations, and it's matter of getting in line to get your case verified that you're worthy of having time on that boat and access to their facilities.
Look, absolutely, Bill, and research funding is notoriously hard to get, but I have to say that industry is really stepping up here as well, and not only in Western Australia, but I'll use Western Australia as an example, where many of the port authorities, for example, many of the offshore drilling rigs who have pipelines on the seabed are working with traditional owners to assess the risks of those infrastructure on this type of heritage. So traditionally, those sorts of port infrastructure, for example, would only consider European heritage, like the impact on shipwrecks or things like that. And what these finds have done just in the last few years is bring to the attention of industry and other stakeholders that there's the potential for a lot of Indigenous heritage in these landscapes. And a lot of industries have really stepped up in their engagement with traditional owners, and they're partnering with traditional owners to fund this type of research in their development impact areas. And I think we're going to see that really productive collaboration between industry and traditional owners pushing this area of research forward into the future.
Australia's got a huge coastline. So how do you determine where we're going to throw down the anchor and have a look?
Well, actually, that's a really pertinent question. So there's a couple of ways we're trying to address this, and one of them is using a lot of that remote sensing, like the work, the bathymetric work that Rob Beeman's doing. But we have access to a whole lot of technology that my predecessors never had access to. So we now have laser units that we can mount on planes and drones that can shoot a laser into shallow waters. So we can actually generate very detailed pictures of the seabed up to around 10 meters using that technology over very large areas. So we're using that to narrow down prospective areas before we even get to the point of putting divers in the water. So when you put people in the water, you're talking a very expensive exercise. So a lot of traditional owners and researchers are using drones routinely in their work now, and that technology has just in the last few years increased by leaps and bounds. That a lot of environmental managers and communities use drones routinely. So we are trying to use those lower cost technologies to narrow down the prospective areas for more detailed work. On the other side, developments like port facilities, for example, are driving those assessments at a much more local level. So coming from the big picture side and the local level side, I think we are going to start filling in those gaps around the very, very long Australian coastline.
It was interesting with Rob's thing, because what drew my attention was his imaging of the Fitzroy River and its scouring of the seabed, or what would have been the landmass then in those days. And that was very well defined. Do all rivers provide that ability to sort of trace their movement right across this, or is other rivers, because of sediment flow and other sort of things, haven't etched their path over the shelf as well as those have?
Yeah, it's really, really good point, Bill. I'm just going to share my screen again, just as a very quick example. So this is an example of our reconstruction of where rivers would have flown in Torres Strait. So these rivers on the western side of Torres Strait are flowing into that very big Lake Carpentaria down here. But a lot of the western Torres Strait Islands, you can see that the river catchments are flowing east. Now, the way we've constructed these models is using the bathymetry from Rob Beeman and then using geographic information system flow models to look at the way water moves across the landscape. Now, we get into trouble when the past rivers have been silted up, because the bathymetry shows them as silted up, not as a channel. So some of these are almost certainly real features, and some of them are artifacts of the geomorphology of the landscape. So this is a very quick example, and we've actually done these maps all the way around the Australian coastline as a very quick first order. Now, Bill, you're probably and a lot of your viewers are probably very familiar with this area, that the big elephant in the room in this picture is the southern coast of New Guinea, where the Fly River Delta brings millions of cubic meters of sediment into the Gulf of Papua every year. In fact, so much so that 8,000 years ago, the southern coast of New Guinea was kilometers north of where it is now. and all of this coastline has pergraded out from those river systems. So whenever we try and do this, we call it landscape reconstruction, mapping of rivers and the vegetation that was on them. We actually need to think about geology and sedimentation and sediment load, but also scouring from cyclones and tsunamis and other things as well. So these are really quick and dirty exercises to begin our thinking about what might have been. And it gives you an idea that these are not featureless plains. You know, I think in a lot of people's imagination, if we remove the water from our, from the beach next to where we live, we're just going to have a sandy bottom. But nothing could be further from the truth that in the past, these were very diverse landscapes with rivers and mountains and trees and grasslands that Aboriginal people managed through fire technologies, for example, and had their camps and villages and settlements on as well. So it's really a shift in our thinking about how these now underwater landscapes were used.
And also how fast they retreated from there and where they went to, and hope they had good neighbours next door to take them in.
Absolutely. And look, I think the reality is that those changes would have required a lot of social adjustments, and it may well be that that led to language change and changes in rock art and the changes in the way people live. And there are sometimes detailed Indigenous histories about some of those things, and other things like archaeology help us get access to those things too. But I think one of the things here, Bill, is that there's so much we don't know about Australia's history. And I think, this is something that all Australians should be very proud of. The very deep, extraordinarily diverse history of Australia is something to be really celebrated.
Well, it's been a very interesting conversation. We've learned a lot and really appreciate your time. We've gone a little bit over the hour, but I'd really like to thank you for your time tonight. That's appreciated. And if you could just stay on the line, if you just want to wind up with anything in particular first, in regards to going forward is your research, anything on the books?
Oh, there's always a lot on the books, Bill. So actually, I think there's a number of really exciting things, and I'm really pleased to have the opportunity to talk with you. The conversation didn't go the way I expected it to, which is always a bonus, I think, when we do these things. But like, there is so much exciting work happening all across the continent that I think all of us, including myself, who is involved in quite a bit of this research, I think there'll be dramatic surprises in store for us. And I think there will be things we don't expect to find. And it's only because this research is happening now, and it's happening in collaboration with Indigenous communities and on a bigger scale, that I think we've got the opportunity to understand things in a way my academic ancestors never had the opportunity to do in the past. And I think that's extraordinarily exciting. I just want to give a plug for a couple of things. That there's a couple of new TV series coming out which highlight some of this work, and a lot of the work led by Indigenous communities. One of those series I was involved with is called The First Inventors, and there's a trailer on the internet if you want to Google The First Inventors. It's being produced by Channel 10 and NITV, and it features a lot of the stories we've touched on today in a lot more detail, but also many, many more stories from Indigenous communities all across the continent. And I think the effort there is to bring really robust, informed stories to a wider audience. And I think, a lot of people are genuinely really interested in these stories, but there's very little accessible information out there in the public domain. And I think the conversation we had today is a really good example of one of the channels to get some more of that information out there, and maybe make a few people curious about finding out some more information too.
Especially about their own country. I mean, when you think about it, human recorded history is fairly short, and then when you put on top of that the ability to monitor and keep records, and that is even much shorter. So it's not just in Australia, but it's all over the world. We don't have that full deep history, and archaeologists all over the world are still finding things about our past, about our ancestors, and drawing different conclusions that would have been drawn 50 or 60 years ago, or even 20 years ago. And I think that's probably going to be something that's going to continue as there's more digs, more information. Satellites probably make a big difference now, because the terrain can be mapped, from space sort of thing, without even venturing out. So your targets are a lot more identifiable, rather than Indiana Jones trekking through the jungle to find something we've already found it from space. Now we just got to find it underneath the ground that we're going to look at.
Bill, I think that's the key, that modern archaeology is only possible with all of the extraordinary expertise in other disciplines, ranging from genetics to, literally astrophysics and other things, but importantly, working in partnership with Indigenous communities. And I think the real future of our past is going to be rewritten because of the strength of those collaborations. And, I think that has extraordinary power. And I think the thing, I wouldn't mind saying to end this out is that these things we're finding out about our past all over the globe are really informing our future. It's not just an idle curiosity. All of these finds are actually helping us understand climate change in the past, for example, how our ancestors adapted, etc. So I think we've ignored for too long the power that understanding can bring to the modern setting. And I think in the future, we're going to be able to capitalize on bringing all of those disciplines together in a really robust way.
I think one of the other things is it will show us our interconnections to each other more than what we knew before.
Absolutely.
Okay, look, thanks very much for your time tonight. If you could just stay on the line, I'll just wrap up the show and introduce next week's guest. If you liked tonight's show, please like, share, and subscribe to our Facebook page, and also subscribe to our YouTube channel. Next week, I'll have Perry Conti on discussing the crime situation in Cairns and far north Queensland, and the actions of ordinary people and what they can do. Thank you.